Okay, so we have all of these parameters, and there's two basic things we're looking at. We're looking at where it increases, where it decreases, and where it's positive and where it's negative. Okay, so two basic things, increasing and decreasing, and where it's positive and negative. And this is describing all of those things, and there's a lot there, so we're gonna just kind of break this down and do each part individually. Okay, so this is the problem. The first thing they're going to ask is, they're going to say f is increasing when x is less than 0 and x is greater than 4. So with increasing and decreasing, what I like to do is I like to actually draw lines in the points where these things are happening. So at 0 and at 4. So f is increasing when x is less than 0. So here's 0. I know it's increasing here. So I have these arrows here. You can also draw maybe an arrow like that. And it also says that it's increasing when x is greater than 4. So here's my line for 4, and it is increasing in there somewhere. It could be down here, it could be way up here, but we know that it's increasing. Which, if we look at the next one, then that makes sense that this would be decreasing somewhere, right? So it looks like it's going to do this. It's going to be positive and of odd degree. Okay, and that's this part. So f is decreasing when x is between 0 and 4. So here's 0 and 4, it's decreasing. Okay, so there's that part. Next we have when things are positive and when they're negative. Now it's going to start looking a little complicated. I did put lines in for these, but really what you need for these, look at the numbers that you're given, and these are your pivot points. This is where things cross the x-axis. So they're going to cross at -2, and they're going to cross at 3 and at 5. Okay? And then what this one says, so it's positive when x is between -2 and 3 and when x is bigger than 5. So I shaded the area that it's going to be in. All right, where the function is going to go. And then it makes sense that the other is where it's going to be. Okay, in the negative area. Okay, so now it's time to actually sketch it. So what I've got this increasing, and it's got to be down here. So this is increasing. It's going to cross the x-axis right here, and it's going to increase till I get to this orange line. Then it's going to start decreasing, and it's got to cross right here. So it's decreasing until it hits this orange line, and now it's coming back up, and it's increasing. So there is my function. Now it asks me, it says use the graph to describe the degree and the leading coefficient. Well, the degree, since I've got one going down and one going up, okay, that's odd looking, right? Odd, odd, okay, it's odd. And since it's going in a positive direction, then we know that the leading coefficient is positive. So this could be x cubed. It could be 5x, well, it can't be 5x. It's got to be something like this, but it's probably cubic. Okay, I know that's kind of a lot. You might have to watch that a couple of times. I did want you to try one. Let me pause the camera for just a minute while I write that one down. It says, sketch a graph of the polynomial function having these characteristics. So this first part is where it's increasing and decreasing. And this is where, again, I say I like to draw the lines. So they have, the main things they've got here is -1.5. So let's do 0.51. This is -1.5. okay? And 2.5, so 1, 2, 2.5. And I like to draw kind of separate the graph going this way. All right, and it says that when x is less than negative 1.5, so this area right here, and greater than 2.5, it's decreasing. All right, so in this area it's going to decrease, in this area it's going to decrease, which means f is increasing between this area and this area. So it's going up here, and that makes sense. This is going to, you know what, I should do it this way, I apologize. This way and this way. Okay, so it's going to look like this. All right, now, I'm going to use a different color. X is positive, f of x is positive when x is greater than negative 3, so 1.5. I'm going to put a dot at negative 3. That's where it's going to cross the x-axis. And there's also, it's going to cross at 1. And it's also going to cross at 4. Like this. Okay? So, it's positive when f of x is positive, when x is less than 3, so it's going to be up in this area right here. Okay, up in here. And then it's going to be negative, so it's going to be down here, and then positive again. Okay, so now let's look at how we're going to do this. It starts off positive, and it's got to cross here, but then it's going to switch directions on these lines. So I'm coming down, crossing through here until I get to here, and now I'm going up, but I've got to cross through here. So this is coming through, increasing, 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 until again I hit that line, and now I am decreasing and I have to cross the x-axis right there. So we've got two different things going on. We've got where it's decreasing and increasing, and where it's positive and where it's negative. So hopefully that makes sense. You may need to watch these a couple of times. That was supposed to be a try this on your own. I don't know if I said that earlier. I hope I did. And then finally, your homework, again, this is on big ideas. You don't have to do it on big ideas and in the book, 'cause it's the same problem, the same problems, okay? But in case you can't get onto big ideas, here it is. And just to help you out with your homework a little bit, we have to remember, what is the commutative property? Okay, the commutative property is the same thing as saying x plus a equals a plus x, okay? Or a times x equals x times a. And then what is x to the m times x to the n power? Well, if our bases are the same, we add the exponents, okay? So this is x to the m plus n. All right, so these two things are going to help you with your homework. All right, if you've got any questions, let me know.